Welcome to the Ready Academy. Tools for teaching, tools for learning, tools for life. In this video book, we cover the 4 laws of thermodynamics. This content was produced with AI assistance and reviewed by a human instructor. We'll continue with the Zeroth Law, temperature as equivalence, thermal equilibrium, and the transitivity postulate. Two systems brought into thermal contact may exchange heat. After enough time, the exchange stops. The systems are then said to be in thermal equilibrium. The Zeroth Law generalizes this observation into a logical structure. Zeroth Law of thermodynamics. If two systems are each in thermal equilibrium with a third system, they are in thermal equilibrium with each other. Said differently, thermal equilibrium is a transitive relation. If A is in equilibrium with C and B is in equilibrium with C, then A is in equilibrium with B without needing to be tested directly. Figure 6 shows the picture. Figure 6, 3 labeled boxes A, B, and C arranged in a triangle. Solid double-headed arrows connect A to C and B to C, each labeled thermal equilibrium. A dashed double-headed arrow connects A to B, labeled therefore in thermal equilibrium. Beneath the diagram is the caption, Transitivity defines temperature. Why this defines temperature? The transitivity postulate has a profound consequence. There must exist a numerical label, the same for every system in mutual thermal equilibrium, that we can call the temperature. Two bodies have the same temperature if and only if they are in thermal equilibrium when allowed to exchange heat. The third body in the postulate is what makes a thermometer work. A thermometer is body C that we calibrate once and then use to compare every other body to it, without bringing those bodies together. Common temperature scales include the Celsius scale. Water freezes near 0 degrees Celsius and boils near 100 degrees Celsius at standard atmospheric pressure, the Fahrenheit scale, and the absolute Kelvin scale. The Kelvin and Celsius scales share the same degree size. They differ only in 0 point. Equation 1 gives the conversion between the Celsius and Kelvin scales. T sub K, the absolute thermodynamic temperature in Kelvin, equals T sub Celsius, the temperature in degrees Celsius, plus 273.15. The constant 273.15 is fixed by the modern definition of the Kelvin. The lowest possible temperature, absolute 0, is exactly 0 Kelvin, equivalent to negative 273.15 degrees Celsius and negative 459.67 degrees Fahrenheit. Fahrenheit and Celsius are related by. Equation 2 relates Fahrenheit to Celsius. T sub Fahrenheit, temperature in degrees Fahrenheit, equals 9/5 T sub Celsius plus 32. Since the 2019 SI redefinition, the Kelvin is no longer tied to the triple point of water. Instead, it is fixed by assigning the Boltzmann constant, the exact numerical value 1.380649 times 10, to the negative 23 joules per Kelvin. We will meet that constant again in the second law. Converting temperatures. A laboratory cryostat reads negative 196 degrees Celsius, the boiling point of liquid nitrogen at 1 atmosphere. Express that temperature in Kelvin and in degrees Fahrenheit. Step 1. Apply equation. 1. T sub K equals negative 196 plus 273.15, which gives 77.15 Kelvin. Step 2. Applying equation. 2. T sub Fahrenheit equals 9/5 times negative 196 plus 32, giving negative 352.8 plus 32, which is negative 320.8 degrees Fahrenheit. 77.15 Kelvin, or about negative 321 degrees Fahrenheit. Why Zeroth? The first 3 laws were named in the 19th century, before anyone realized that the existence of temperature itself rested on a separate, more primitive postulate. Ralph H. Fowler and Edward A. Guggenheim, in their 1939 textbook Statistical Thermodynamics, gave the postulate its modern formulation and proposed the backform name Zeroth Law, precisely so that it could be added in front of the first law without renumbering the others. The exact year of first coinage is contested in the historical literature. A 2012 commentary in the Journal of Chemical and Engineering Data, after examining publication lists, concluded that the term zeroth law was first coined by Fowler in 1936. That is, neither in 1931 nor in 1939. Whether 1936 or 1939, the 1939 textbook of Fowler and Guggenheim is the work that fixed the name in standard usage. Zeroth Law in action. Two identical sealed flasks A and B sit on a bench top. A digital thermometer reads 22.0 degrees Celsius when inserted in flask A, then reads 22.0 degrees Celsius when inserted in flask B a minute later. Without bringing flasks A and B into thermal contact, what does the zeroth law allow you to conclude about them, and what does it not allow you to conclude? Pause the video now and give it a try. That wraps up the Zeroth Law, temperature as equivalence. Next up, Section 3, the first law, conservation of energy. If you found this helpful, like and subscribe and support the channel.